Welcome to Unit 5, Lesson 8, Position, Speed, and Direction. We're going to start today with the warm-up. Our learning goal is let's use sign numbers to represent movement.
Miss Mark Lee, please call the main office, 299.
We're going to start number 1. An airplane moves at a constant speed of 120 miles per hour for 3 hours. How far does it go? Number 2, a train moves at a constant speed and travels 6 miles in 4 minutes. What is its speed in miles per minute? Number 3, a car moves at a constant speed of 50 miles per hour. How long does it take the car to go 200 miles? Pause the video to answer these questions now. Welcome back. Let's take a look at the first one. So an airplane moves at a constant speed of 120 miles per hour for 3 hours. How far does it go? So this question is asking us how far is this moving in 3 hours? So we would do 120 times 3. 3 times 0 is 0. 3 times 2 is 6. 3 times 1 is 3. It's going 360 miles. Let's take a look at the second one. A train moves at a constant speed and travels 6 miles in 4 minutes. What is its speed in miles per minute? So it's telling us it needs to be miles per minute, which means we would put miles over minute. So we would have 6 over 4, or 6 goes into 4 one whole time with 2 left over, so we would have 2/4, or 1.5. So its speed is 1.5 miles per minute. And the last one, a car moves at a constant speed of 50 miles per hour. How long does it take the car to go 200 miles? So we would have 200 over 50. And because there's zeros there, we can just cancel it out. 20 over 5. 5 goes into 20 4 times. It would take 4 hours. All right, let's go to the next page. Okay, 8.2, going left, going right. After each move, record your location in the table. Then write an expression to represent the ending position that uses the starting position, the speed, and the time. The first row is done for you. So if we look, they did the first row for us. It started at 0, so I'm just going to go ahead and put in our 0. And it went right 5 units per second for 3 seconds. So we can go 5, 10, 15. So it made 3 jumps, and it went 15 units. They then wrote that down over here as a positive 15 and the expression. So now we're going to be moving left 4 units per second for 6 seconds. So starting at 0, we're going to go 4, that's once, go 4 again, twice, 4 more, that's 3 times, 4 again, that's 4 times, 4 one more time, for 5, and once more for 6. So our ending position is at negative 24. So we started at 0, and we had to go 4, 1, 2, 3, 4, 5, 6 times. So we did, and that was going negative, we did negative 4 6 times. So we have negative 4 times 6, and that's going to give us the negative 24. Let's look at the next one. So we're going, again, starting at 0. Here's my starting point. We're going to go right 2 units per second 8 times. So let's go 1, 2, 3, 4, 5. Oops, that went a little too long. 6, 7, 8. And we're going to end here at 16. So we started at 0. We went 2 seconds, or 2 meters each second for 8 seconds. So we would do 2 times 8. Our next one, we have, again, starting at 0, we're going right 6 units per second for 2 seconds. So we're going to go right 6, that's 1 second, go 6 more, that's 2 seconds. We ended at 12. So we started at 0 and we went 6 units for 2 seconds. So we have to multiply that. Our last one, we start at 0 again. We're moving left 1.1 spaces for 5 seconds. So we're going to go 1, 2, 3, 4, 5, which would put us at about 5.5. So we started at 0. We went 1.1 units per second for 5 seconds. And part 2 to this question is asking, how can you see the direction of movement in the expression? So how can you see the direction of movement in each expression? Oh, this last one was supposed to be negative 1.1. Yeah, so when we see a negative in front of the answer, it means we're going left. When there is a negative, times a positive, we go left. Positive times a positive, we go right. All right, let's look at the next question. Using a starting position P, a speed S, and a time T, write 2 expressions for an ending position. One expression should show the result of moving right, and one expression should show the result of moving left. So our position at top, remember the 0 was where we started, the speed was the distance we went, and the time was the amount of time it took. So pause the video and try to think of 2 ways we could write this. Welcome back. So we could have our P plus S times T, because we ended up multiplying these 2 together. Or, and this would show us going right. Or if we want to know how to go left, we would have P times negative S time, nope, not times, add. We're adding right there. Times T. Okay. Let's move on to the next page. We're going to look at some velocity. A traffic safety engineer was studying travel patterns along a highway. She set up a camera and recorded the speed and direction of cars and trucks that passed by the camera. The positions to the east of the camera are positive and to the west are negative. Vehicles that are traveling towards the east have a positive velocity, and vehicles that are traveling towards the west have a negative velocity. So on this side, it's negative, and over here, it's positive. Our camera is at 0. So let's take a look at our table. Complete the table with the position of each vehicle if the vehicle is traveling at a constant speed for the indicated time period. Then write an equation. So if we look at the first one, they were traveling 25 meters per second for 10 seconds. So their ending position was 250 meters. The equation we have is 25 times 10 equals 250. So we're going to follow that same pattern over here, but let's start with our equation. So we have negative 20 meters per second for 30 seconds. So we would need to do negative 20 times 30 equals 600. So we would have positive 600 meters. Let's look at the next one. 32 meters per second for 40 seconds. So we would start with our 32, multiply that by 40, and 32 times 40 is 1,280. So we would have positive 1,280. Let's look at the next one. We have negative 35 meters per second for 20 seconds. So negative 35 times 20. And this is a negative times a positive, so the answer is going to be negative. So negative 35 times 20. Well, we know if we multiply 35 times 2, that's going to give us 70, and we have to add in a 0, so it would be negative 700. Negative 700. And our last one, our meters per second is 28 for 0 seconds. So we would have 28 times 0, and any number multiplied by 0 is 0. So our ending position would be at 0. Number 2, if a car is traveling east when it passes the camera, will its position be negative or positive 60 seconds after it passes the camera? So it's traveling east. So it's going in this direction. So would that be positive or would that be negative? That's right, it would be positive. So it would be positive 60 seconds after passing the camera. All right, and then the second part says, if we multiply two positive numbers, is the result positive or negative?
Well, two positive numbers is kind of what we do before we even got into this unit, right? If we did 2 times 3, we knew the answer was going to be 6. So a positive times a positive will always be positive. All right, question 3. If a car is traveling west when it passes the camera, will its position be positive or negative 60 seconds after it passes the camera? So let's go back up here. We're going towards the west. After it passes the camera, is it going to be positive or negative? That's right, it's going to be negative because it's going in a negative direction. Negative 60 seconds after passing the camera. All right, and if we multiply a negative and a positive number, is the result positive or negative? Well, let's look at our table. When we multiplied a negative and a positive number, what did we get? A negative number. So a positive times a negative will be negative. Amazing. Look at that. We are all done with that page. Let's move on to the next page. Oh, that's the end of lesson 8. I will see you next time.